Soap versus detergents. Both soap and detergents are surfactants, which mean they have molecules with both hydrophilic and hydrophobic parts. When soap or detergent is added to water, the hydrophobic tails of the surfactant molecules cluster together, forming structures called micelles. The hydrophilic head of the surfactant molecules then face outward, with the hydrophobic tails pointed inward towards the center of the micelle. In other words, the genius of soap functions around two different ends to the soap, which is polar on one end and non-polar on the other. The cleansing action of soap and of detergents are determined by their polar and non-polar structures in conjunction with an application of solubility principles. In the case of soap, the hydrophobic head is usually a carbon dioxide polar carboxylate group of CO2 molecules, as highlighted here in yellow, which is negatively charged and bonds with water molecules, more specifically with the hydrogen from the H2O, as it is the only negatively charged atom in the polar molecule, where according to Coulomb's law, opposite charges attract, hence their bond. Soap molecules are relatively large and bulky, which can make them less efficient at removing oily or greasy stains. On the opposite side of the tail, however, strains of CH2 molecules create a strong non-polar covalent bond with one another, evidently non-polar due to the same charges between the same molecules, and covalency as carbon and hydrogen are nonmetals, as a result repelling water due to its covalent nature. In other words, this repelling nature is due to water being a polar molecule and CH2 being completely nonpolar. Therefore, CH2 or hydrocarbon, as well as other hydrophobic molecules in the chain, will forcibly interact with each other instead of with water. Then, through its strong covalent bonding with one another, it allows the formation of a cellular-like structure called the micelle. This structure is formed through a combination of clusters of hydrophobic particles, as one could see here. As it creates a strong bond of clusters of CH2, the result is the evident rejection of H2O bonds. This formation of the micelle is the reason for which separation happens between dirt and water, as it repels all H2O due to its form and strong bonding nature, acting as a filter and separator between the dirt and grease and between the water. In contrast, synthetic detergents have smaller and more compact molecules, which can make them a lot more effective at penetrating and breaking down oil and grease. Detergent molecules typically have a hydrophilic chain made from hydroxide or OH atoms, whereas its hydrophilic chain is similar to soap, made from hydrocarbons CH3 or CH4 molecules. Despite the use of very similarly charged molecules between soap and detergents, the heavily compacted and small size of detergents molecules drastically increase their effect. Their particles, as can see here, are often derived from petroleum, and the hydrophilic head that can vary depending on the type of detergent, cationic meaning positive and anionic meaning negative. In the end, despite their different molecular structures, both go on to form a micelle separating the water from the oils and grease. However, in the case of detergents, instead of appearing circular, the micelle molecules or the nonpolar hydrocarbon tails are repelled by the water, which makes them appear to stand up rather than bulk together, as you could see in this graph drawn right here. This is due to the relatively smaller hydroxide molecules in comparison to the larger CH2 molecules that find it a lot easier to bulk up with each other rather than cluster up. Hard water tolerance. Soap is less effective in hard water, meaning water that can contain high levels of dissolved minerals like calcium and magnesium, because the calcium and magnesium ions can react with the soap to form insoluble soap scum, as you can see on the image on the right. Detergents, however, are designed to be more tolerant of hard water and are less likely to form scum. This is due to soap molecules being typically ionic, with a negatively charged head and a positively charged tail. The ionic nature of soap makes it more likely, as I said before, to form insoluble scum in hard water. Detergents, on the other hand, are non-ionic or very weakly ionic, as you can see here on the right, which makes them less likely to react with dissolved minerals in hard water as the amount of chemicals reaction lessen. In order to conclude, each of the cleaning liquids have both their pros and their cons, with their covalency, ionic bonds, polarity, and charge playing a major role in their behavior and efficiency. Thank you.